Okay, today's lesson is on 3.1, graphing relationships. We have a bunch of vocabulary words. The first one is discrete, or a discrete graph. You'll use this a lot this year. A discrete graph is a graph made up of distinct, unconnected points. So you put in your dots, but you don't connect the dots. The next vocabulary word is a continuous graph. Continuous is a graph made up of connected lines or curves. So you connect the dots. And then here's some examples of discrete graphs. So you put in your points, you don't connect them. This is usually word problems where it doesn't make sense to have the in-between answers. So I may have a graph of how many goals you made at a soccer game. You can't make half a goal. You can't make a quarter of a goal. You can only make those exact goals, so you don't connect the dots. Where continuous, you do connect the dots. It might include everything in between. Okay, this domain and range, the next two words, these you started learning about last year, and then we're going to get a little bit harder this year with them. Okay, domain, this should be review, but your domain is all the input values in a function, also called the x-coordinates. The range is all the output values, also called the y-coordinates. So a lot of times you guys will see a T-chart. Usually the domain is on the left for the x's and the range is on the right for the y's. Or you'll see it on a graph. The x-axis would be your domain, the y-axis is the range. Or when you have a point, a coordinate point, x is domain, the y is the range. Okay, so here's an example. Here's some x and y's. I'm just going to go through and label them. Every time you have a point, it's always x comma y. X comma y, x comma y, x comma y. So to list the domain, we're just listing out the x values. So there's a 4, there's a -1, a 7, and a 9. And the range is the y values, 3, 5, 2, and 1. Those of you that had me last year, you know I drilled this into you. The domain and the range is the x and the y's. Okay, next, the first example is on story graphs. So you learned this in 8th grade. Story graphs are types of graphs where there's typically not numbers. It usually has some type of scenario. So for this one, it's 3 hoses are filling 3 different water barrels. A green hose fills a water barrel at a constant rate. A black hose is slowly opened when filling the barrel. And a blue hose is completely open at the beginning and then slowly closed. The 3 graphs of the situations are shown. Okay, the one I usually start with, that's the easiest to find, is anything that has the constant rate. Constant rate of change, you guys know that from last year from 8th grade. If it's constant rate, it's going to be linear, it's going to be a straight line. So the one that has the straight line is the middle one, so that's the one I'm going to do first. That'll be the green hose. So you just turn on the hose and you don't adjust it. Water just starts coming out at some type of pressure and it just keeps coming out at that same pressure. Okay, I have a black hose that is slowly opened. So I would assume most of you guys have dealt with the hose. Your parents might ask you to go outside and hose something down. So when you turn on the hose, They're slowly opening it. So when you turn that little nozzle, you're doing it slowly. So the water starts coming out slowly, right? And then you adjust it. So the one where it shows the water is coming out slowly, and then you start adjusting to have more pressure, that's the first graph. So that will be the black hose. Because the water starts coming out, the gallons of water come out slowly, and then you maybe give it a little bit more pressure. You need more. Obviously, this last one's going to be the blue hose. And for the blue hose, it's completely open at the beginning and then slowly closed. So you guys have probably done that where you turn the hose on all the way. It's coming out way too much, so you're getting a bunch of gallons of water at first, and then you kind of tighten it up because you don't need it coming out as hard or as much water coming out. Okay, then let's go to these type of story graphs. These ones you probably saw a ton last year in 8th grade. Segment 1 shows the person is moving away from home. Okay, so this whole graph is talking about moving from home. So that means down here, you're at your home. When you're all the way up here, this is going to be the furthest from home. So you're at your house, you leave to go somewhere. This is the farthest you're ever going to get from your house. Then you're going to turn back around, and when you get back here, you're back home again. So it's a graph that's talking about you're starting at home, you're walking at a constant rate, you stop, you turn around, and you're coming back at different constant rates. Keep in mind when you have a straight line with a constant rate, the more steep it is, the faster you're going. So during step 1, you're going fast. I don't know, you're riding a bike, you're something. So you're going fast because that line is going up pretty quickly. Then it kind of peters off a little bit, so you slowed down. So maybe you got off your bike and you started walking, and you were walking your bike. Then you realize, oh, I need to get there. So you get back on your bike, so you're going faster because the line is going up very quickly. Then you get wherever you are and you hang out for a little bit. So your distance from your house hasn't changed for a little bit because you're at your friend's house or something. Then you start coming home. Okay, so let's look at the questions. What does segment 2 show? So segment 2 right here. Does it show the person is moving back home? No, they're still going away from their house. Letter B, the person is still moving away, but a slower rate. Yes, because the part 1 is they're going fast. Part 2, they're still going away, they're just not going as quickly. Letter C, the person is not moving towards or away from home. No, that would be during step 4. The person quickly stopped, but is still moving away from home at the same rate. They haven't stopped at all. If they stop, it's going to flatline completely. Okay, based on the time frame, what does segment 5 represent? So we were stopped. Segment 5 is when you start coming back home. Which line segment shows an interval where the distance did not change? So time kept going on, but the distance didn't change. That's during part 4. Whenever it flatlines, the y did not change, so distance didn't change. And what's a possible explanation for that segment? It's just when you're stopped. So time kept going on, but you're stopped somewhere. So you're at your friend's house, you're at school, you're at wherever you wanted to go. Okay, go down to 1C. This is similar to the hose question. John, Gary, and Angela are all driving at different rates. John is driving at a constant rate. Gary starts out slow, but then gradually builds up. And then Angela starts out fast and then slows down. So again, I always start with the constant rate one. That's always the easiest because that's going to be a straight line. So the graph that has the straight line is the third graph, so I would label that first. So he is going at a constant rate. He's not stopping. He's not slowing down. He's not speeding up. He's going the exact same speed. Okay, Gary's going to start out slow, but then build up speed. So starting off slow, looking at those two graphs. Starting off slow and then gaining speed is going to be your second graph. This is Gary. He starts off slow and then starts picking up speed. And then the first graph is Angela. She starts out fast, but then she starts to slow down. Okay, go to the on your own. There's 3 scenarios. Go ahead and put the numbers 1, 2, or 3 by the appropriate graph that it fits. Okay, so your answers are, number 1, you throw the ball and your friend catches it. So imagine when you throw a ball, when you're throwing it, at what height is it off the ground when you're throwing it versus when somebody catches it? It's usually about the same. The catch might be a little bit higher. Number 2, you throw a second ball and it lands or gets stuck in a tree. So it's going to be up and it's stuck up there. And then number 3, you throw the ball and it's going to land in front of your friend. So it's going to land on the ground. Questions there? Okay, now this is where it gets harder. Example 2. Continuous versus discrete graphs. We're going to sketch a graph of the situation. Tell whether if it's continuous or discrete, and then determine domain and range. So you're going to be doing this a ton for algebra this year. Is graph it, tell me if it's continuous or discrete, and determine domain and range. 2A, a student is taking a test. There are 10 problems on the test. For each problem the student answers correctly, the student receives 10 points. Okay, I already put the graph on there, so you don't obviously need to graph it because the graph is here. So when you look at the graph, you can get one problem right. If you get one problem right, you get 10 points. You can get 2 problems right and 20 points. 3 problems right and get 30 points. You cannot get half a point. You can't get half a problem right. You're not going to get partial credit for anything. You either get the answer correct or it's wrong. So you can't get those in-between parts. You can't get half right. You can't get 3.5 right. So we don't connect the line because you can't get the in-betweens. So because we're just putting the dots with no connection, that is a discrete graph. Okay, then domain. So domain is your x values. So the smallest x value I can use, so ignore the y's right now. The smallest x that's there is there's a 0. Then there's going to be a 1. Then there's a 2. Then there's a 3. Then a 4, a 5, until there's 9, and then there's 10, right? You can't get 9.5. You can't get the in-between parts. So the way we write this, to show that it's going to be 0, 1, 2, 3, 4, 5 through 10. We're going to write it the way we wrote your inequalities. So because I want to write it like the inequality statement, those intersections, the and statements, I'm saying that x can be greater than or equal to 0, right? Because it can be 0 or it can be greater. Or x can be less than or equal to 10. So the way I show this, like we did in the previous lesson, I put the smallest number first, then I'll put my variable in the middle, I'll put the largest number at the end. X can be less than or equal to 10. X can be greater than or equal to 0, so the greater part is facing the 0. Or no. Is facing the x, sorry. Greater part is facing the x, so make sure the greater part is facing the x. So you're going to write down 0 is less than or equal to x, that is less than or equal to 10, and then you also have to add, because it's not every number, it's only our whole numbers. So you have to put that, only whole numbers. So you're going to state that it's only 0, 1, 2, 3. It can't be 0.2 or 0.5 or 1.6. Okay, for the range is only looking at y values. So when I'm looking at just the y's, so ignore the x-axis, the y's. The smallest y that's on there is 0. Then it goes 10, 20, 30, 40, 50, 60, 70, up to 90, up to 100. So again, the smallest goes first. Whatever variable you're using, we're using y. The largest goes last. Okay, I'm going to do the back end first. Y can be 100 because, yes, 100 is one of the y values that's used, so put an equal sign. And then y can also be anything that's less than 100. Okay, y can be 0, so put your equal sign on 0 because it can be 0. And then it's anything bigger, so y, facing y will be the bigger part. Now here, it's 0, 10, 20, 30, blah, blah, blah. So you're going to put only multiples of 10. This is probably the hardest thing we do. Okay, let's try this one. A bathtub is being filled with water. After 10 minutes, there's 75 quarts of water in the tub. Then someone accidentally pulls the drain plug while the water is still running and the tub begins to empty. The tub loses 15 quarts in 5 minutes, and then someone plugs the drain and the tub fills for 6 more minutes, blah, blah, blah. Okay, a bunch more stuff happens. I did not give you the graph. We are going to actually graph this one. So we're going to go through the word problem sentence by sentence and start filling it in. Okay, so it's being filled with water. After 10 minutes, there's 75 quarts. Okay, so let's deal with this first part. After 10 minutes, there's 75 quarts of water. So let's look at our x and y axis and make sure we have our intervals. So looking at the x-axis, 0, blank, 10, blank, 20, blank. So what are these going up by, everybody? So if you want to, you can fill in the additional ones if you want to, if that helps you. Okay, on the y-axis, 0, blank, 30, blank, 60, blank. What's that going up by? That's going up by 15. 0, 15, 30, plus another 15 is 45, plus another 15 is 60, plus another 15 is 75. Plus another 15 is 90, plus another 15 is 105, plus another 15 is 120. So if it helps, fill in all the intervals. Remember your intervals, it has to go up at the same rate. However, the x and the y don't need the same rate. Like the x went by 5s, the y went by 15s. Those don't need to be the same. But whatever you're going up by, you have to go up the entire time by that rate. Okay, it said after 10 minutes, there's 75 quarts. So go to 10 minutes, go to 75 quarts, and put a dot. 10 minutes, 75 quarts, put a dot. Okay, I need to figure out if I'm just going to leave dots or if I'm going to connect the dots. So if you're filling the water in the bathtub, could I figure out how many quarts of water are in there at 5 minutes? Yeah. Could I test at 2 minutes and see how much is in there? 2.5 minutes. So you can find in any of those numbers. So you're going to connect, so you're going to need a straight edge, because when you're filling the water, you're just leaving it running, and it's running at a constant rate. So get something that has a straight edge on it. It could be a folder, a notebook, and make it a straight line because it is increasing at a constant rate. So for 10 minutes, you just let it run, and it just keeps filling with water at a constant rate, so it gets a straight line. Okay, then the words say, then someone accidentally pulls the drain plug while it's running. The tub begins to empty. So the water was going up. Now it's going to start coming down. The tub loses 15 quarts in 5 minutes. The tub loses 15 quarts in 5 minutes. Okay, so for time, right now we were at 10 minutes. 5 minutes later means we're going to be at what time? 15 minutes. It says it loses 15 quarts. So it was at 75 quarts. It lost 15 quarts. 75 minus 15 is 60. So go find 15 minutes and 60 quarts and put a dot. And then connect that with a straight edge because the water is draining at a constant rate. Okay, then someone plugs the drain and the tub fills for 6 more minutes, gaining another 45 quarts of water. So 6 more minutes. So we were at 15 minutes. Now we're going to go 6 minutes. What's 15 minutes plus 6 minutes? Okay, so we're at 21 minutes. So figure out about where 21 minutes is. It said it gained another 45 quarts of water. So we were at 60 quarts of water. And then we added on, it says another 45 quarts, so we're going to be at 105. So figure out where 21, Brody, bring me your phone. Put it on my desk. We're at 21, and we're going to have 105 quarts. So go 21 up to 105. Where am I? There I am. And put a dot. So somebody plugged it and then started filling it again at a constant rate. Okay, then they took a 15-minute bath. So when you're in the bath, you stop the water and, just sit there and marinate in the disgusting water. So that's 15 minutes. So it was 21 minutes, right? We were at 21. So for 15 minutes, 21 minutes plus 15 minutes. What's 21 plus 15? I heard a couple different numbers. 21 plus 30, what did I say? 21 plus, plus 15. 36? Yeah. Okay, everybody agrees now. 36, so figure out where 36 would be. Maybe about right there. They're sitting in the water. So that means it hasn't drained and it hasn't increased. So at 36 minutes, it's still at 105 quarts of water. So just put a dot there. Connect it with a flat line. That just means the same amount of water is still in there. So you're taking a bath, you just leave the water, you don't drain it, you don't fill it. Okay, then you finish the bath, you pull the plug. It takes 11 minutes for the tub to drain. So 11 minutes. We were at 36 minutes. Now 11 minutes later, where are we at? 47. So figure out where 47 is. You're going to drain the whole tub, so it's going to go down to 0. It's going to go all the way down to the x-axis. Grab your straight edge, connect that, because it's draining at a constant rate. Okay, this type of graph, we connected the dots, so it's called continuous. Okay, the domain. So domain is all the x values, so ignore the y. Just looking at x, the smallest x and the biggest x. So the smallest is 0. We're using x, so put x in the middle. The biggest x is 47. Okay, x can be 47 and anything less than 47. X can be 0, and then it's everything greater than 0. And then it can be everything in between, because I can figure out how many quarts there are at 22 minutes, 23 and a half minutes. I can figure out everything here. So just leave it as that. Okay, the range is the y values. So the smallest y we're going to use, ignore all the x's, the smallest y that's used is 0. The biggest y that is used is 105. So put the smallest first. I'm going to use y. The biggest one is 105. Okay, it can be 105. It does get what it hits exactly at 105, and then it hits everywhere below. So y is less than or equal to 105. Y does hit 0, so put part of your equal sign. And then y is everything greater than 0. So 0 is less than or equal to y, which is less than or equal to 105. Okay, we're going to stop there. We will continue this lesson on Monday. You don't have any homework or anything for this yet.